Alright, for my physics problem, I'm supposed to explain how this equation, Ez equals charge density over 2 epsilon naught times 1 minus z over, or 1 minus z over z squared plus r squared can be used to find the electric field on an infinite plane of charge. Now we probably recognize this equation as a way to find the electric field for a disk. So let's say here we have our disk in our three-dimensional space, three-dimensional coordinates, and here it has a radius of r, normally in the equation. Now let's say we just keep on expanding this disk over and over and over again until this r goes to infinity. So now we can take the limit as r goes to infinity of the charge density over 2 epsilon naught times 1 minus z over root z squared plus r squared. Alright, so as the limit of r goes to infinity, this whole term is going to approach 0, because as the bottom gets bigger, that's going to make this bottom huge, a huge number. No matter what this number is, it's going to be very small. So as it gets to infinity, this number, or this term, approaches 0, which means you're just multiplying 1 times this. So the new equation would be charge density over 2 epsilon naught. Now this is the equation we can use for an infinite plane of charge. So let's say here we have this infinite plane. We're just drawing it from a different perspective, because as we expand the disk over and over again, it's going to begin to look like an infinite plane. So here we have this infinite plane right here. Let's just say this goes on forever, and we pick any point above it. Now some people may be wondering, oh, why is there no like height term in here? Because what if we choose a point like up here or down here? Like, why does that not matter? Well, that's because this distance goes on to infinity, and this right here is just a finite point, which is why it doesn't appear in our equation. So we can use this equation for any point away from an infinite plane to find out what the electric field is. Alright, thank you.